Hi, my name is Shashank Singh Kumar and this is my video lab report for Physics 2211 Lab 3 Black Hole. The following are the contents of my lab. The following are some concepts of significance. Newton's second law is a significant idea which can be expressed by the following formula. F net is equal to delta P by delta T. Newton's second law of gravitation is a significant idea which can be expressed by gravitational force Fg is equal to G into mass of the star into the mass of the black hole by r square into r hat. Formulas of significance are as follow. Net force is equal to dp by dt. Newton's second law, F net is equal to dp by dt parallel by dp by dt perpendicular. The purpose of the experiment is analyzing the motion of a star around a black hole through a computational model and calculating the net force on it and hence calculating the mass of the black hole. I have made a diagram describing the motion of the star around a black hole, and I have also provided a brief of the results. The mass of the black hole is 1.04102 into 10 to the power 34 kgs. This was derived by the F net value, which is 9.08304 into 10 to the power 28 newtons, which was further divided into its perpendicular and parallel components. The parallel component being 4.12571 into 10 to the power 28 newtons, and the perpendicular component being 8.072669 into 10 to the power 28 newtons. Here is the calculation used in order to calculate the mass of the black hole. I have also provided a label diagram of the different aspects and parts of the motion used in GlowScript. Here is the coding for the computational model for part 1, the seed setup and initial conditions. The arrows point towards the lines which have been edited, and I have also provided a link to my GlowScript code. The seed has been set as my Georgia Tech email ID in order to make the trajectory of the black hole unique. The mass of the star has been set as 2 into 10 to the power 30 kgs. Delta T was calculated by multiplying 24 hours into 60 minutes into 60 seconds in order to set the number of seconds in a day as the time period. Here is the calculation loop which shows us the sequence followed by the algorithm in order to calculate the mass of the black hole MBH. P initial is calculated by multiplying the mass of the star with the initial velocity. P final is calculated by multiplying the mass of the star with the final velocity. Delta V was calculated by subtracting initial velocity from final velocity. Delta P was calculated by subtracting initial momentum from the final momentum. dp dt was delta P divided by delta T. F net was dp dt. P hat is the normal of P final. d mag P dt is the magnitude of P final minus the magnitude of P initial divided by delta T, and dp dt parallel is d magnitude P dt into P hat. F net parallel is dp dt parallel. dp dt perpendicular is dp dt minus dp dt parallel. F net perpendicular is dp dt perpendicular, and r is the displacement of the position of the star from the original position. Hence, MBH is the mass of the black hole calculated by multiplying the magnitude of F net by the magnitude of displacement squared and the whole divided by gravitation multiplied by the mass of the star. The last part was edited in order to display the arrows to represent forces. The following video along with the legend displays the output resulting from the GlowScript code. The following is the coding of the computational model for part 2, system properties and initial conditions. I have also provided a link to this new GlowScript code. The mass of the black hole is added from part 1 and the speed of the ship is obtained through trial and error. The calculation loop. The force of gravity on the planet by the black hole is calculated. The force of gravity on the planet by the spaceship is calculated. Hence, by adding these two previous forces, the net force on the planet is calculated. The force of gravity on the spaceship by the black hole is then calculated, and then the force of gravity on the spaceship by the planet is calculated. Hence, by adding these two previous forces, the net force on the ship is calculated. Newton's second law is used in order to derive the new velocity and position values for the planet. Newton's second law is used in order to derive the new velocity and position values for the ship. The following is the motion of the ship around the black hole in accordance to the values used in the GlowScript code. Answering the what if and what does it mean questions. What does it mean? What is the difference between the net force and its parallel and perpendicular components and the rate of change of momentum and its parallel and perpendicular components? What if? What initial velocity would your spaceship need to have in order to enter into some kind of orbit around the black hole? The gravitational force of the black hole and the moving planet must be considered in order to calculate the speed required. However, I just used trial and error. I used the x component of the speed as minus 9 into 10 to the power 5 meters per second and the y component as 1 into 10 to the power 7 meters per second. Thank you very much for your time, and I hope that this presentation was useful.